Hi, I'm Eric Lenask. We're here at Editor's Day in Santa Clara, and I'm talking with Stan Schneider from RTI right now. Stan, thanks for joining us. Great to have you here.
Oh, thanks. Great.
So, a lot of exciting things happening, lots of different devices and just things being connected to each other. Tell me a little bit about how RTI kind of fits into that whole giant puzzle.
Okay, so our mission is to enable smart machines for the benefit of mankind, but we are in the space of the industrial Internet of Things, so it's quite a bit different from the consumer Internet of Things. Consumer Internet of Things is about wearables and smart refrigerators and thermostats. We're more about a new infrastructure for the future of the industrial economy, so we do things like traffic control, both air and ground traffic control, autonomous vehicles, autonomous planes, medical systems that can put together intelligent devices in hospitals to check on doctors and make sure that they don't make mistakes. Today, the hospital error is the third leading cause of death in the United States. Somewhere between 200 and 400,000 people a year die from mistakes in hospitals. It could easily be prevented by an intelligent distributed system. We also do a lot of power systems. We're doing big hydroelectric dams with hundreds of thousands of control points, as well as Siemens Wind Power's big wind turbines. And really the most exciting thing going on in the power industry today is something called microgrids, which is really all about making solar energy and distributed energy resources in general really efficient, because today, shockingly, if you have a solar panel on your house, that actually is not reducing fossil fuel burn much at all. Maybe 20% of the power actually goes to knocking down fossil fuel burn, and the rest of it is essentially not doing that. It's a hard, long story, but the grid's not smart enough to handle that.
I'm not sure that most people would have realized that.
I don't think most people realize that at all, because it's not well publicized by the industry for obvious reasons, but happy to go into that if you'd like.
Well,
I can explain it.
Let's talk about RTI's role in making all these different things possible.
Right. RTI has a high-performance network connectivity system. It's sort of like a database for moving information. So think of it as a way to share everything you need in a system, exactly the right data, exactly the right time, to exactly the right place. Distributed systems in general are all about the data. You'll hear data, 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 data everywhere you go. But the data isn't, just trying to get it somewhere. The most important thing about the data is to get the right data to the right place at the right time. My favorite example is traffic control, and the most visual one is air traffic control.
Okay.
So if you think if you're trying to write a collision detection for a landing system at an airport, there's 50,000 planes in the air. You can't look at every one of them and have every single piece of it trying to figure that out. Our software can do things like, show me or send me just information from planes that are within 5 miles, below 5,000 feet, descending and coming towards me. Guarantee me that there's absolutely no path into the airport that isn't covered. It's an important thing. We call that optics on the data. Guarantee me that it's going to be updated in a hundredth of a second. Guarantee me that I'm not missing anything, that I've got multiple redundant ways to ensure that data is actually correct. We provide all of that sort of data reliability and availability in a way that other kinds of technologies don't. And it really is allowing much easier construction of large, complex, distributed, intelligent systems.
So who's the buyer?
The buyer is system designers for large systems. So if you're building an automated substation of the future for automated, substation automation vendors for the power grid that today are used to the old way of, power generator substation users, and now you've got generator substation, solar power, wind power, all these distributed things, and your software and your systems can't handle that. We can make that relatively easy to do it. Obviously, you can't buy just one thing. We're working with a lot of standards organizations. There's actually a large organization called the Industrial Internet Consortium, if you've heard of that.
Sure.
It's now the largest of the alphabet soup of Internet of Things consortia. I'm actually on the steering committee, which is like the board of directors. RTI is very involved in that. We actually lead or co-chair the use case, security, data distribution, data management, safety. Many of these things we're actually working to build an architecture that can span sensor to cloud, interoperate between vendors, and really go across industries, because it really isn't internet. People don't get that. They hear the Internet of Things, and they don't get the idea, especially in the consumer world, it's not so much an internet. It's really just your little wearable leveraging the current internet to get to the cloud.
Right.
But the industrial internet actually is an internet that's able to connect these sensors and devices and actuators together into intelligent distributed systems that just isn't around today. And that's the exciting future that allows you to have autonomous vehicles running in traffic-controlled streets, and autonomous air vehicles flying in national airspace, which we'll have very soon.
So you're talking about these autonomous vehicles or autonomous planes communicating with each other through this through the industrial internet.
Yeah, well, it's not that simple. The thing that's really powerful is being able to communicate not only between vehicles, but between the vehicles and the infrastructure. Mm-hmm. So, just like my air traffic control system, where I want to be able to know which planes are coming in and arrange them so they don't hit each other. An intersection controller on a highway would need to know, I need all the vehicles that are coming towards the intersection. Same probably thing. I don't care about the ones that are leaving. I don't care about the ones that are in Toledo. I care about the ones that are coming towards my intersection and potentially interacting with other vehicles coming to the intersection. To do that, you need to be able to connect between vehicles so you can sense where they're going, what they're going to do. You need to be able to connect the vehicle to the infrastructure. And you need to do it at rates and reliability that are sufficient to be safe and fast and secure in the environment. So,
what are the challenges with processing those volumes of data information and obviously then returning real-time data to be able to those vehicles or whatever you have,
right.
The target being able to process that and react?
The biggest challenge, first of all, is reliability of availability of data. So making sure it's always there, pervasive availability of data, and with what we call quality of service, to make sure it actually is there when you need it to be there. The lack of information we'll stick with the traffic control problems. The lack of there's a vehicle coming towards the intersection isn't useful information if you aren't guaranteed that there's actually active sensing on that possible path. So you have to have, really quality available data to make that work.
Got it.
So the biggest challenges, really are the challenges are reliability, no servers that could fail that could cause the problem, and full redundancy. Performance, measured typically in our world in milliseconds or microseconds. Scale, which can be hundreds or even thousands of interacting applications, which you really don't find in the consumer world at all.
Of course.
And then also another metric of scale, which is really how much data is there, because you said volumes and volumes of data. If you get more than about 10,000 different separately addressable data items, you can't send everything to everybody anymore. It just doesn't make sense. Mm-hmm. And so you hear Cisco talk about fog computing and things like that. That's
sure.
A way to talk about having intelligence in the field.
Right.
This whole power grid thing I was talking about is actually called a field message bus by SGIP, which is a big standards industry effort. But having intelligence in the field doesn't do you any good unless you can get the right data of that intelligence and communicate with the other sources of intelligence. We look at the whole world as sort of a data sea, a moving data river, and we are going to pick out exactly the right parts to send to the right people. And if you think about the ability, what I just said, to select just these few airplanes, in this case, coming in to my traffic controller, you can knock down the volume of data from 50,000 things to just the 7 or 8 that are coming towards you have to deal with. So that's a huge part of that, is being selective data availability, so you don't overwhelm systems.
Excellent. Makes a whole lot of sense. Certainly,
Sorry for being too technical there. I don't know.
Certainly, a lot of exciting implementations and potential projects that are very relevant here. Stan, thank you so much for joining us. It's been a great pleasure.
No problem. Thank you.